In this next part, I want us to explore short division a little further by introducing you to slightly higher numbers other than 2, and I'll mix up both whole number answers with decimal answers. Let's start with a nice one. 5 into 625. Well, 5 into 6, well, that goes 1, remainder 1. Remember, the remainder always goes below the line. Then we say 5, not into the 2, but 5 into 12. Well, that goes 2 times, remainder 2. And again, the remainder slides along to the next digit coming up. So finally we say 5 into 25, well, that's just 5. So our final answer was 125. It was an exact whole number answer. There was no decimals involved. Okay, let's introduce one with the decimal answer. Let's do 5 into 468. Now 5 into 4 doesn't go, but I'm not going to put a 0 because we haven't started to record our answer yet. I'll now simply say 5 into 46. Now I may know this answer or may count on my fingers, but either way I'll find that 5 goes into 46 9 times with 1 left over, with remainder 1. Well, I now say 5 into 18. Well, 3 5s gives me to 15, so that's 3, remainder 3. Notice how my remainder has gone below the line, even at the end, as it were, of the initial digits present. Now, if you recall before, we said, if I have a remainder by itself, this is when I go into the decimal region. So I put a point below the line, and make sure I put a point, crucially, on my answer line. But now I say 5 into 30, which is just 6. So 5 into 468 is 93.6. Okay, well, let's push it a little further. Let's now do 3 into 612. Well, 3 into 6, that's a nice easy start. That just goes twice. 3 into 1 doesn't go. Now we've started to record our answer. That 2 is there in front of us. So because we've said doesn't go, we must put a note, and the one that doesn't go gets carried. I've written it as a specific carry next to the 2 to make 12, or you could have just simply in your mind's eye said, look, 3 into 1 doesn't go, put the note, but then say 6 into 12. Either way, we finally say 3 into 12 goes 4 times. So that was a little tricky with that introduction of the 0. Okay, moving on. Let's now do this one. 8 into 102. 8 into 1 doesn't go. No need to put a 0 just yet because we haven't started to record our answer. 8 into 10, well, that goes 1, and look where I recorded that 1 above the end of the 10. There's 2 remainder, to put the 2 there. 8 into 22. Now 8 goes into 16 twice, and the remainder is 6. So my remainder goes below the line at the end of the last digit. I've got a remainder by itself, so I must go decimal. That was the clue, to go decimal. Below the line I put a point .0, and above the line, crucially, I put the point. We now say 8 into 60. Well, I know 8 sevens are 56, so that will be 7 times remainder 4. This is quite tricky because I've now got another remainder. What do? I have another remainder by itself. Now it would make no sense to put another decimal point, but we can, in such instances, keep going by simply adding another 0. We haven't changed that value of 102. We've simply rewritten it in the first instance as 102.0, and now as 102.00. Anyway, 8 into 40, well, that does go. That goes exactly 5 times. So this one took us a little further into the decimal region. All decimals we've seen so far, including this one, are called terminating decimals. They do end, whether after 1 or more decimal places. Okay, that brings us on very nicely to this question, 6 into 73. Now 6 into 7 goes exactly once, remainder once, sorry, it didn't go exactly once. 6 into 7 went 1, remainder 1. Then 6 into 13, well, that goes 2, also remainder 1. So far so good, and there's no cause for alarm bells. We have remainder by itself, so put a decimal point above and below and add the 0 below the line. 6 into 10, well, that's 1, remainder 4. Again, we're not alarmed. We think, still got a remainder, put another 0. 6 into 40, well, 6 sixes are 36, so I'll put 6 down, remainder 4. We have another remainder, we'll put another 0. Well, 6 into 40, well, that's still 6 remainder 4 again, and now you see not a problem but an interesting pattern emerging. This question will never end. The answer is 12.16 recurring. Now, what mathematicians do is put a little dot there. If you were using this in an applied way, for example, if you're doing a nursing calculation, you would never put an answer with the recurring marker above that final digit. You would do something like rounding or something. I'm simply showing you how a mathematician might show this, but this is an example of a non-terminating decimal, a decimal answer that never ends. And this is not uncommon, and you'll see it on a calculator often when the digits just go to the very, very end. So just look out for this. As I said, if you're applying mathematics to something like drug calculations, you would have to think about ending your calculation at some point. Okay, I want to show you how tricky this idea of recurring can be. I want to do 7 into 85. Now notice I've made that answer line rather long in anticipation of some fun and games. Okay, bear with me, but don't worry too much about following exactly all the answers, because 7 times table isn't necessarily everybody's favourite times tables. 7 into 8 goes 1 remainder 1. 7 into 15 goes 2 remainder 1. Remainder by itself, go decimal, add a point below. 7 into 10 goes 1 remainder 3. Keep adding a 0. 7 into 30, well, that's 4 remainder 2. 7 into 20, well, that's 2 remainder 6. 7 into 60, well, that's 8 remainder 4. 7 into 40, well, that is 5 remainder 5. 7 into 50 is 7 remainder 1. 7 into 10 is 1 remainder 3. 7 into 30 is 4 remainder 2. And at that point I'll stop, because if you've been paying attention to the answer line emerging, you will notice it is a recurring decimal, but not the same digit. It's a recurring pattern. If you look, we had 142857, and now it's starting off again because of the way that these remainders occurred. If I was a mathematician recording this, look how I would do this. This is just for interest. This isn't really of any practical use per se. You would write down the starting and ending digits for the repeated pattern, I beg your pardon, and you put a dot above the first and last digit of that. So a mathematician would write it down like that. Of course, most people would just say, look, I'm just going to write that as 12.1 to 1 decimal place, or something like that. You don't have to worry in most courses outside of mathematics about such subtleties, but I did want to warn you of that and make you aware with both the divide by 6 example and now the divide by 7 example. Sometimes you get non-terminating decimals, answers that don't behave that well, as it were, and you have to do a little bit of thinking to decide at what point do I stop with this. Okay, well, hopefully that helped you be reminded of some of the more common features of short division, as well as forewarn you of some issues that can threaten to catch you out if you're not careful. But thank you for that.